Hello guys, my name is Diego Pacheco and this is another Rust video. Today we're gonna do a very simple, silly, dummy closure parser in Rust. So this is not really a serious parser. Um, this is more like a POC for fun. I was inspired by Sam Rowe's video, and that was the base code. And also I did some changes, I improved some things, and add some new operations. But like the main idea, I got it from Sam Rowe's. Um, so let's get started. Hopefully, will be fun. So I have this POC I'm doing. Let's get there. I'm opening my idea. And we can see how we can write this closure or Lisp parser in Rust. So this is quite simple. As you guys can see, I have no external dependencies, which is good. We're just using the standard library. Okay, and it's not that big at all. This is the whole code. There's some tests in the main class here, so these lines doesn't count. So it's really 75 lines of code, so it's pretty short, right? So let me get this bigger for you guys, and we can start. So you will have expression or Lisp code or closure code, something like this, that you're gonna evaluate, right? And one of the problems of this parser is you need to have spaces between all the tokens. Often in closure you could write some code like this, right? But this parser is not smart enough, so you can't. So the first thing you want to do is to want to tokenize that, and then you want to evaluate some operators and keep doing that until you just have one element on a stack. We will be using stack and a queue. In Rust we use a dequeue to have that queue. I'm using a queue as improvement because I want to have ordering on my arguments, and that's why I'm using a queue instead of a stack. So let's start with this evaluate, see what's going on there. That's the main function. So you receive a Lisp code, and which is a string, right? An expression, closure expression. Then we have this hash map of string and fn, and we're gonna return a string. So the evaluate of our parser are gonna be a string. So first, let's take a look what is this hash map. So this hash map, there is this function called ops, where I'm returning a hash map of string and fn. So here we build a hash map, and we are populating here with the operations that we support. So I'm supporting the plus operation, minus, multiply, and also the inc function in closure. So in here are the functions that should be called for plus, for minus, for multiply, and for inc. So this OPFN, if you are not familiar with this type, this is an alias defined right here on the top. So to define an alias in Rust, you say type, the name of type, and then here you put the signature. So this type, as you guys can see, is a function, is a closure, where this function receives by parameter dequeue of the generic type string, and returns a string. That's all. So that's the default operations that we are supporting that's gonna be passed here. And the code, the first thing that the code does, it tokenizes it, right? And that's something really common on parsers. And now you're gonna see why the parser is simple, is why the parser is limited. Because I'm getting easily all the tokens, just splitting the string by white space and collecting that. And then I have a vector of stir with all my tokens. Then these tokens are printed right here, All right. And now we have a main stack in order to evaluate the expression. And this expression can have sub-expression. So what you want is at the end to have one element in the stack, and that means you are done. And once this code is done, we're gonna see, okay, does the stack has one and only one? If the stack has one and only one element, this means we can pop, which is an option. So in Rust, when you do pop, as you can see here, you have an option, right? So we need to unwrap, right? So I'm gonna do pop.unwrap, and that's it. We finish it evaluating, right? So if you go back to the main app, we have this result as a string here, and it's just being printed here. Okay, so now let's understand what happens on the main loop, right? So we create this queue, which is create this stack, which is a vec of string. Then what we're gonna do is for each token, it's calling token ref, right? From the tokens, the first thing we're gonna do is to transform that token from a view of stir to a string. Okay, and then we're gonna start evaluating. So if by any means that token is an open parenthesis, we don't want to do anything, all right? And then we move on. The only thing we do here is really to move on. You see here, there's nothing going on here, right? But if the token is a closed parenthesis, well, then there's a bunch of things we need to do. But let's say it's not that. Well, if it's not an open parenthesis, it's not a closed parenthesis, then it's else. And then what we want to do is just to add the token to the stack. And it's very likely that the token is either a character, like a string, or a char, or a number, right? In our case, it's going to be a number. Okay, so when we see this, okay, now we need to do something. It means that because we're closing this, we have an operation, right? So the first thing we're gonna do is to figure out if we have an operation, and we also need to collect the arguments to pass to this operation. So that's here where I'm gonna have a mutable queue, and this queue is used to preserve ordering. So there will be a loop that basically will pop the main stack, all right? And if there's nothing there, we break free. Otherwise, we return the type. With this type, we just gonna send that type to the front of the argument queue, right? So this type can be two things. Imagine that it can be a value, right? It can be a letter like A, B, or C. Could be a number, A, B, or C, and there's all values. Or it could be an operation like plus, minus, inc. All right. So what we need to check is, are we dealing with operation or not? So if we have this hash map of operations, so if T, if the view of T, it is present on that hash map, it means we have an operation. So we need to break from here, right? Otherwise, we keep doing that, right? So on the queue, we're gonna have all the arguments, right? So now moving forward, if we are here, it means that we break it from the queue, because this is an infinite loop. And if we break it from the queue, the last item we push it, as you can see this code here, was an operation. So we need to get that out of the queue. And that's exactly what we do. We get that out of the queue. So we have the string representation of the operation. And luckily, it's one of those that I have it right now. So it's plus, minus, asterisk, or inc. So what we will do is we're gonna get that from the hash map. We're gonna unwrap it because it's optional. And then we're gonna call it because it's a function. And we're gonna call it passing the queue of arguments. And here we're gonna print the sub expression being evaluated. And then we're gonna push that back to the queue. And we're gonna repeat until there's just one element. And that's pretty much the whole parser. Here, I can run the main app so you guys can see it's working. You guys can see right here, right? So here, all the tokens, they are completely correct. And then the the args here, or the first evaluation is being these ones here. The args is 3 and 4, and we preserve the order. The sub-eval is 7, because plus 3 and 4 is 7, so it's correct. Then the next evaluation is 1, 2, and 7. This guy is here, right? 1, 2 is here, and 7 is the result here. And it's plus as well. So 1 plus 2 is 3, 3 plus 7 is 10. So that's the sub-eval, and that's the whole thing. So it works, right? Here there's a bunch of unit tests for evaluate, for plus, for minus, for multiply, and also there's one here for inc. And here are the functions, right? So for plus, we're receiving vec the q, which is a q with string. So the first thing we need to turn that into numbers, and I32. So we're gonna get the args, we're gonna iterate them, we're gonna map them, we're gonna parse the string. In that way, we're gonna get a vector of I32. Then we're gonna go again and we're gonna fold it. And for plus, we're gonna start on 0, and we're gonna have an accumulator, and we're just gonna sum the value of the accumulator, and that's it. That's how we sum, and this line gonna be returning. With minus, it's pretty similar. The only difference is we need to get the first element. We cannot subtract from 0, like here. This wouldn't work. So we need to drop the first element from the queue, and once we drop, then we can continue with the rest of the queue, and we can subtract from each other. With multiply is similar than fold, but you need to start with 1 instead of 0, because otherwise your multiplication it will not work. And my implementation of inc, enclosure, when you do inc, you increment whatever you have there plus 1, right? So what I do here, I transform my string args in vec of I32 args here. Then I'm concatenating this, because this is like a list collection in enclosure here and here, right? And then what I'm doing is like I'm getting my I32 arguments and doing a map, and I'm getting whatever value they have there and adding 1, and then turning that into a string, collecting into a vec, but joining with comma, right? So in that sense, we can have then as a collection. I have this test here. I can run, so you guys can see here how it looks like here. So I have inc 2, 3. It will get 3 and 4. Okay, so that's it for today. I hope this is fun for you guys. See you next time. Take care. Cheers.